All right. All right. Well, okay, no problem. All right. So I'm just starting the second video. That's where you heard that funny noise. But you're good with this. So far, so good. Okay. Now, if you want, you can play with this. Now, it doesn't often happen this, but I'll show you anyway. If you have a load of chlorine, excess chlorine, like lots of chlorine now, what happens is your product, your your chloromethane will react with more chlorine and you'll get CH2Cl2 plus HCl, and then your CH2Cl2 will react with more chlorine to give CHCl3 plus HCl, and then your CH3Cl, whoops, yeah, that's right, CH3Cl3 will react with more chlorine to give you CCl4 plus HCl. So this is consecutive substitution. In other words, we substitute one, then we substitute another, then we substitute another. Now, the first one here, let's start at the top. CH3, what's this? Have I done that right? This is yeah. CH3Cl. That, as you know, is known as chloromethane. All right, the next one, let me do a different color here. This one is called chloromethane. The next one is called chloromethane. And the next one is called chloromethane. Obviously, that's not right, is it? So I've got to put something in. If you've got one chlorine, we call it monochloromethane. If there's two chlorines, it's dichloromethane. 3, it's trichloromethane. And 4, it's tetrachloromethane. All right. Now, that's if you have excess chlorine, and you get further and further substitution. So you can make all these substituted products. If you've got the CH3Cl, that's known as the monosubstituted product. Okay, and if you, I don't know, let's do the third one, CHCl3, this is known as the tri-substituted product. Does that make sense? Oh, yeah, excellent. Now, the reason I say that is because this word here, this mono-substituted product, yeah, they'll often say that. And if a question says, what is the mono-substituted product? All it means is you're adding one thing. You mustn't add two things. You're adding one thing. All right. So what's the mono-substituted product of chlorine plus methane? It's monochloromethane. I hope that makes sense. Are we good? Excellent. If I'm going too fast, guys, you've got to tell me. I do tend to go quite fast on these because I think, these guys are smart. They'll deal with it. All right. So now let's go to the next step. Let's have a look at propane. There's propane. A nice propane molecule. All right. Now, here we go with propane. Now I'm going to subject this to ultraviolet light and chlorine, and I'm going to subject this to ultraviolet light and chlorine. Now, 1, 2, 3, 1, 2, 3. Okay, I'm going to get this. And I'm going to get this. They look the same at the moment, but they're not going to be the same. Trust me. Okay, and I'm going to get a chlorine there and a chlorine there. So, Azim, what's the top one called? Since you said you're good at names. All right. So, Axel, do you want to guess top one? Well done. It's 1-chloropropane. And the bottom one is obviously 2-chloropropane. This is for Azim, can you get 3-chloropropane? Why? That's right. Well done. Well done. So it's 3-chloropropane would be the same as 1-chloro, wouldn't it? Does that make sense? Yeah, okay. So would you both agree that these are mono substituted products, aren't they? Both of them, this and this, are mono substituted products. In other words, they've both got 1 chlorine on. So you're going to get both of these. Okay. With methane, it's easy. You only get, it's easy to see where the chlorine goes. But if you've got this, you're going to get the 1-chloro and the 2-chloro. Now, I can't honestly remember if I did this with Axel. If I did, you can't say anything. If I didn't, you can guess as well. What ratio will I get these products in? What ratio will I get the 1 and the 2? Anyone can answer. No. So, honestly, why would I give you something so easy? Oh, yeah. We're here at 6:45 on a Wednesday night. No one wants trick questions, trust me. What? Why? No, as if I'm going to stop. No, stop. Stop. All right. Now, the sad thing is, you're both going to get this. You're going to understand this totally, and you're going to think, "Oh, why didn't I think of that?" Because it's easy. Now, watch. How many places can the chlorine substitute to make 1-chloropropane? It can do this one, this one, this one, this one, this one, and this one. How many places is that? Exactly. Or 6, 2. Now, guys, couldn't you have done that? Well, you can. You will in future, I hope. Okay, so 6-2 or 3-1. So you're happy with that? That's the sort of thing. Unfortunately, guys, that's the sort of question they ask. Eh? All right. So you got to be careful. Um, if I did, all right, I'll ask you a very quick one. You've got to answer this quickly. If I've got butane, 1, 2, 3, 4. Okay. And I only want to talk about the mono substituted product. So, first of all, how many mono substituted products are there? If I add 1 chlorine, is it 3? Yeah, it's going to be 2. And it's going to be 1-chlorobutane or 2-chlorobutane. Yeah. There's no 3-chlorobutane, is there? Because it's the same as 2. Are you with me? So I think we'd all agree in this case, you're going to get 1-chlorobutane and 2-chlorobutane. Now, while I'm writing this, I want you to figure out the ratios. What's the ratio going to be between 1-chlorobutane and 2-chlorobutane? Well done. So you understand my point. Yeah. Well done, guys. Excellent. Now, that's the mechanism for free radical substitution. Okay. And that's the first one. It's a lovely one, isn't it? I think it's really sweet. And I didn't tell you this, and perhaps I should have done, but we start off with an alkane, and we end up with what's called a halogenoalkane. Now, an alkane is a boring thing. Okay, these are very boring, and they are non-polar. Okay, and they don't do much, and we don't like them. They burn. You can use them as fuels, but other than that, they're pretty boring. Halogen are not boring. You can make these into loads of things. So these are polar molecules, okay? And they're used to make other things. Used to make other things. So and this is a big thing, if you're given an alkane, you can't do anything with it. What you've got to do is you must convert it to a halogenoalkane first. And then once you've got the halogenoalkane, you can do loads with it. Okay? So this is you must remember this. If you're ever given an alkane and you're told, I've got to make something with it, the first thing you've got to do is ultraviolet light and chlorine, because you've got to make the halogenoalkane. And then once you've got the halogenoalkane, you can do loads with it. But you can't do anything with an alkane. Are you good with that? Anyone? Okay. Now, yeah. Yeah, I'll explain what I mean by that, because I think I should have explained this a bit better. Okay. Yeah. Bromine. Yeah, it's got to be a halogen. Yeah. Yeah, it's got to be. Yes, it's good. Bromine, fluorine. I know what the other ones are. Chlorine, iodine. All right. Now, alkanes. Alkanes are quite boring, aren't they? They're CnH2n plus 2. And a good example of an alkane is propane. Okay? Now, alkyls are CnH2n plus 1. Let me draw propane. My internet seems to be dying a bit because the pen is lagging a bit. It always happens. It's so annoying. That's propane. All right. And now let's have a look at this thing here, this alkyl. That's 3 carbon atoms. All right, here we go. There. Now, there's no hydrogen on the end. Now, propane exists on its own. This has an existence on its own. All right, there's such a thing called propane. But this guy here is not propane, it is propyl. Now, propyl is part of a molecule. Okay, it sticks onto something. Does that make sense? It could, but it won't live for long. It will snag something from somewhere, and it will form something else. But propane, propane is propane, but propyl exists as part of something else. Okay. In other words, it sticks onto things. Now, these things that stick on that don't have their own life, they're known as alkyl groups. Now, alkyl groups are given a special letter, and the letter that alkyl groups are given is R. We say they're called R groups. Now, that's an alkyl. So now you know what an alkyl is. If I have ROH, what type of homologous series is that? Exactly. It's an alkyl group attached to an OH. Now, if the alkyl group is an ethyl group, the alcohol is exactly. And if the R group or the alkyl group is a propyl group, the alcohol is propanol. Are you with me? So an alkyl group is an alkane with a hydrogen knocked off, so it's part of another molecule. So ROH is an alcohol. This is an alcohol. But as Axel said, I think it was Axel, I can't remember now, but R-hal. What's an R-hal? It's an alkyl group attached to a halogen. And this is a halogenoalkane. They're called halogenoalkanes, but their general formula is an alkyl group attached to a halogen. Often we see these as RX as well, where X is a halogen. What's this then? RCOOH. No one? Yeah, that's a carboxylic acid, isn't it? All right, so you get the idea of an R group. Now, we never do this ever, 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 but if you had RH, what would that be? Yeah, but no one ever does that, eh? Okay, but it would be an alkane, you're quite right. So that's the sort of nomenclature we use. We use these R groups. Okay, so you're good with that. So far, so good? Are we good? Everyone's gone. Axel, you still there? Okay, excellent. Now let's do. So that's free radical substitution. Now, and that's pretty well all of it for alkanes. There's not much about alkanes. So we're going to go to alkenes now. Alkenes. Okay, and let's do some naming. Naming of alkenes. All right. So the first one, let's have a look. 1, 2, 3, 4. There's a double bond there. And 1, 2, 3, 4. There's a double bond there. Now I'm going to put my hydrogens in. They're all over the place. And the hydrogens are the one at the bottom. Oops. And there's one, and there's one, and there's one. So, as I'm sure you both know, that the top one is butene, and the bottom one is butene as well. They're both butene. Now, obviously, the only difference is where the double bond is. And what we do is what we always do in organic chemistry, we number the carbon atoms. So this is 1, 2, 3, 4. 1, 2, 3, 4. And what we do is we say, well, the double bond is where it starts. So in the top one, it starts at number 1. So the top one is known as but-1-ene, and the bottom one, it's but-2-ene. Are you good with that? Excellent stuff. All right, now I'm going to do 1, 2, 3, 4. All right, I'm going to do, what's this? 1, 2. All right. Oh, this is a bit annoying. All right. Now, let me put my hydrogens in here. Okay. Now, what on earth is this monster called? All right. While I'm filling this in, you guys think about what this is called. Mm-hmm. All right. Guesses. I'm open for guesses. Oh, God. Me? No, I don't. Probe? No, I don't think so. What's the first rule you got to? Yeah, I think it's pence. Yeah. Yeah, no problem. Now, the first rule is this, guys. You've got to look for. Now, in the case, this is a tiny, tiny bit harder than alkanes. The first thing you've got to do, if I can get a pen here, is you must look. Where's my. Look for the longest chain. Okay. Now, normally with alkanes, that's all you've got to do. you look for the longest chain. But in alkenes, it's a tiny bit harder. You look for the longest chain which contains the double bond. Okay, now that's slightly harder. It's not much harder, but it's a little bit harder. So you look for the longest chain that contains the double bond. Now let's do that together. Let's get a nice color here, nice green. So it's obviously this one. You see that? This chain is the longest and it contains the double bond. Are you with me? Okay, so what's the name of that green colored thing? Forget everything else, but what's the name of the green colored thing? It is definitely pentene, isn't it? But you haven't told me where the double bond is. Exactly, it's pentoene. So the way you've said it is this is number one, this is number two, this is number three, this is number four, this is number five. What's on my pentoene? Exactly, there's a methyl on my pentoene. So this is called methyl pentoene. Now, the last thing you got to do is tell me where it is. Where's the methyl? A number what? Exactly. So this is 3-methyl pentoene. Are you okay with that? Okay, Axel's quiet. I guess you know this stuff, Axel, yes? Oh, good, good. So you learned something. That's excellent. But it's not hard, though, is it? It's awkward, but it's not hard. All right, let me give you another two here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, now I'm not going to draw. Oh, all right. Now, while I'm drawing the hydrogens, you try and figure out what this is called. It's interesting, actually. Cambridge aren't very big on names, but they can ask nasty names sometimes. IB seems pretty bad on names. They ask a lot of names. Okay, so, oops, daisy. So I hope you're thinking while I'm doing all these hydrogens. Okay, anyone want to guess? Okay, hold on. Let me figure it out myself. All right, yeah, I've got it now. What is it? Oh, hold on. Oh, you let me see. You might be right. You know that. Three what? Three what? Sorry, butyl. I think that. Yeah. What was after that? Hept one ene. What do you think, Azim? You all right with that? Is that because you don't know what it is? Don't be a chicken. All right, let's have a look. I don't know what it is either. So the first thing is, you know why I screwed this up? Because I put the two chains a bit too long now. But the first thing is, we don't count this as the longest chain, okay? Which is exactly what I was trying to mess you up with. We don't count that as the longest chain, okay? So the longest chain is, let me get rid of that. Where are you going? Oh, why isn't it going? I think it's my internet's dying here. All right, let me try and snaffle it away. There you go. So the longest chain in this one is, let me use this blue, is this one. There, and then we go up. Okay, because as I've just told you, the longest chain must contain the double bond. So 1, 2, 3, 4, 5, 6, 7. It looks good, Axel. It's hept, isn't it, for 7. The double bond is at number 1 because you picked the lowest number. So I would agree hept-1-ene. That's good. So far, so good. And now, what's this thing on my hept-1-ene? This thing. And you're quite right. It's a butyl. Okay. And 1, 2, 3. It is at number 3. Axel, you're exactly right. Well done. So congratulations. You're not that happy. Oh, was it you that got it? Oh, Axel, I thought it was you. You know what? I could. Oh, sorry. Anyway, well done, Axel. You would have got it though, wouldn't you? Oh, okay. I'm sorry. No, I don't. You know what? Sometimes I can't see who's talking because I'm looking at the screen. Anyway, guys, next week, if you're still interested, don't forget you might hate everything I've done, but if you're still interested, next week we'll do